Welcome to this morning's webinar, Delivering Net Zero Buildings. I'm Thomas Lane, the technical editor of Building Magazine. The UK has announced the most ambitious target dates to achieve a net zero economy of any country in the world. The Committee for Climate Change has identified buildings as one of the most pressing priorities for carbon reductions between now and 2035. So the pressure to deliver net zero projects is on. On the 20th of April, Boris Johnson announced that the UK was going to achieve a 78% reduction in carbon emissions compared to 1990 levels. So there is not much time. This means all aspects of construction, operation, maintenance, refurbishment, and end-of-life emissions must be considered as never before. This is a major challenge for the industry, and there are a lot of lessons to be learned. Today, we are joined by 4 experts who are pioneering net zero design and construction to debate these issues. I'm joined by Crawford Wright, the Head of Architecture and Design for Schools and Colleges from the Department of Education, Simon Nicholas, the UK Managing Director of the Robert Bird Group, Jesse Putzel, the Head of Sustainability at BAM Construct, and Simon Wyatt, who is a partner at consultant Cundall. So in terms of today's proceedings, each of our 4 speakers will talk for about 8 minutes each, and then we'll move on to a question and answer session. And I'd encourage you to submit your questions and we can answer some of those. So in terms of what everyone's going to talk about, Crawford's actually going to talk about net zero schools, including the DFE's Generations Gen Zero project. Simon is going to cover the whole life carbon considerations of building structures. Jesse is going to talk about net zero from the perspective of construction and include a case study. And finally, Simon's going to talk about the timings for action and the costs, and actually what the costs of inaction could be as well. So without further ado, I'd like to hand over to our first speaker, who is Crawford. Thank you very much, Crawford.
Great. Hopefully you can hear me okay.
Yes.
And
Crawford
slides. So can you see my slides?
We can, yes, we need. Can you maximize, because we can see it minimize on your screen. I can see your desktop. That's perfect.
Great, good. Okay, so I'm Head of Architecture and Design at Department for Education. I run a design team that's actually been around for 70 years or so. So we've been involved in standards of school building since 1951 when we published the first building bulletin. So we've got a lot of history in good quality standards of school buildings, and our job really is to set standards and hold on to economy. But what's really important to us in terms of thinking about zero carbon is we always take a kind of holistic approach to thinking about school design. So we're interested in what a good education building is, which will include zero carbon as an outcome. So we've got 3 things that a good education building is. That it's a healthy and productive environment, that it's the right size, and it's designed to be safe, secure, and sustainable. So again, we've had a look at some of our some previous schools that were built under zero carbon task force back in 2008, and sometimes you get suboptimal outcomes when you don't think of a building environment in a holistic and fully rounded way. We work in a particular way, so we're always interested in a kind of evidence-based approach. So, as I say, we set standards for school buildings. We also support them. We're not an ivory tower organisation. So DFE is the biggest deliverer of school buildings in England, and my team is a multidisciplinary team that provides design advice as well as setting standards. So we support delivery on the ground. So we know how school buildings are built. We then measure quality. So we've got one of the largest post-occupancy evaluation studies, as I say, in the construction sector. We've done nearly 100 over the past 3 years, going back and looking at existing buildings to see how well they perform. It's important to us, I think it's something that's missing in the industry, is that performance gap won't be closed until we spend a lot of time going back and looking at existing buildings to see how well they're performing, and we then draw on evidence from that to continually upgrade our standards. And the overall outcome from that is therefore to get sustainable school buildings and grounds. And again, that's a really important issue for us, and it should be for everyone, that it's the whole site, the whole habitat, not just a building out of context that's important. We've set a 10-point climate change model to drive forward the agenda at school. So that's all about efficient use of space, reducing energy demand, then optimizing energy efficiency. I'm not going to run through all of the key aspects of it. We follow the fairly traditional kind of green model of be lean first of all, and then be green following after that. Again, that's really important to us, that we get fabric first approaches to our buildings rather than focusing on technology. As I say, behaviour is really important to us as well. So it's all about operation at this point, and it's clear that we've got a plan to get to fully zero carbon buildings by 2025. I'll pick that up in a second. Another key aspect in terms of what I mentioned about site is the use of green infrastructure. We now understand that the use of green infrastructure has got multiple benefits in terms of bang for your bucks in relation to building construction. Maximising green infrastructure is a key aspect for us. It will play into a lot of government strategies in terms of the environment, increasing biodiversity, but it has super effects on the building in terms of cooling. It has brilliant effects in terms of health and well-being for the occupants. So we think that's a key area that we should be looking at across the industry. As I say, we collect evidence and we measure quality and we collect evidence. So we've done a lot of R&D projects recently, and Thomas mentioned the Gen Zero project, which is funded by the Construction Innovation Hub and Innovate UK. It's a really unusual project for us because we don't often get chance or the money to do pure research, and this has been a great opportunity for us to really expand the envelope in terms of thinking about what a school building of the future could be. So we developed two prototypes, one urban and one suburban, that are both zero carbon operation, net zero construction carbon, that are really driving standardization and systems thinking. So it's designed for manufacture and assembly. It provides that unified site, the building approaches that I mentioned, that's user-centered, flexible and resilient. As I mentioned, it's got an urban and a suburban solution. So we've come up with a kind of new system for building schools based on a rigorous grade of a mass timber solution. And the studies we've shown, as many of others have shown, that really timber is the only way to drive carbon out of construction. We're going to be building a prototype section of that at the Manufacturing Technology Centre in Coventry. We'd like to build a full-size classroom for COP26, but that's yet to be waiting on future funding. Second bit of evidence that we've done a lot of pilot projects because we're a capital delivery unit, building lots of schools. We can use those schools as test beds. So we've got a Pathfinder project. This will be the first one that we have on site, which is a small primary school in Cornwall, which is net zero carbon in operation. We take a fabric first approach, and we used existing MMC contractors. So this is all about tweaking existing ways of working and improving them. Can we, through normal means of production, deliver much better schools? And again, we've emphasized the use of outdoor planting and green infrastructure. The third project I mentioned is St Mary's Biophilic School. So this will be England's first biophilic school. St Mary's in Derby unfortunately burnt down last year, and we've taken the opportunity to do a development project led by the design team that's going to sort of drive forward the use of green infrastructure for environmental, educational and health and well-being benefits. But again, using principles of standardization, following through our Gen Zero model, off-site construction. Really kind of fantastic opportunity. Again, that should be on site within about 8 to 12 months. We have got a new specification for schools. So all of our schools are built to a very standard specification that's based on all that evidence work that I mentioned at the beginning. But we're about to launch a new version of that, which is net zero carbon in operation. That'll be ready from November 2021. So that's going to put the long-term needs of the school users at the centre of all our decisions, future-proofed against climate change, create a healthy and productive school setting, and prioritise the application of low energy, fossil-free buildings. So we're looking at mitigation and adaptation. So we're particularly concerned about how schools cope with climate change, overheating and flooding, but also about improving biodiversity. And just lastly, I want to just take you through sort of the journey that we're on in terms of meeting net zero carbon. We're splitting this into sort of two aspects. Standards and standardization we think are really key. So standards is all about what can we do and when can we achieve it by. And standardization we think is the best way of achieving that on a large scale program that we're involved in. So we work out through our standards what's the best way to do something, and then we replicate that on as many projects as possible. So we have our Gen Zero learning up front. We're going to combine that with a digital strategy and use the best of information technology to help drive both the delivery of new buildings, the management of existing buildings, a sustainable school strategy, which we're currently in development, which needs to think about the 22,000 existing schools as well as the new buildings that we're building, and a commercial strategy. So a different way of building and procuring and financing buildings. We don't think that business as usual will deliver us the sort of right outcomes that we need. So we've got our new output specification that I mentioned, which will be ready this year. We're going to develop new standard designs based on our Gen Zero model, and we'll be asking contractors to follow those from 2022 onwards. We're going to adopt quality management systems internally. We'll have then a further version of our output specification where we'll set construction carbon targets in 2023, followed by a digital version of our standard designs, which have got parent and child BIM object models. So we'll work out exactly what the best way of delivering something is, and we'll allow contractors to drop down those models. Further development of quality management systems, and then finally, in 2025, a complete output specification which addresses construction carbon as well as operational carbon. Finally, realizing a platform system approach to the delivery of complete new schools in 2025 that will deliver that good quality school building, net zero carbon, health and well-being, and a great quality environment and habitat. So that's the end of my presentation.
Great, thanks very much, Crawford. It's really interesting to hear about the work that you're doing. I mean, with Gen Zero, I mean, obviously it's a huge thing to be doing. Is there anything in sort of particular which represents a really difficult challenge? Because you've got to consider so many things, haven't you, with a net zero school?
Well, I think the same challenges that we're all facing across construction. Can the construction sector deliver net zero carbon net zero carbon construction buildings? And that's the key aspect from our Gen Zero project, is how do you unpick a traditional sector and rebuild it from thinking about carbon and rethinking all of our use of materials, and do so within the current regulatory framework, which may be in some circumstances working against us. Let's say, for example, timber, and reduce the amount of concrete, reduce the amount of materials. We've got our own standards that are kind of working against this, things like acoustics and lighting. And is it time to rethink all of our standards and measures to deliver these sorts of outcomes? And I come back to our understanding of buildings in use, and I think this is a big gap for the sector, is that we don't really know how buildings are used. We design them and then we walk away from them, and we don't really understand over their lifetime how they operate. And I think that's the missing piece for me, is what do we really know about buildings in a much more holistic way?
Great, well, thanks very much. Well, maybe some of the issues you've raised will be covered by our speakers. So actually our next speaker is Simon Nicholas, who is the UK Managing Director of the Robert Burr Group. So if I can hand over to you, Simon.
Good morning, everyone. Can you see my presentation? Am I sharing the right screen?
Yes, it's perfect.
Good morning, everyone. I'm Simon from Robert Burr Group, Structural and Civil Engineers, and I'm briefly going to touch on today the embodied carbon challenges of designing for zero carbon from a structural engineering point of view. As a business, Robert Burr Group are committing to a zero carbon future. We are currently developing with the use of science-based targets, a route map for the business to become zero carbon, and we'll be signing up to the business ambition 1.5 degrees later this year. As a business, our scope 1 and 2 emissions are relatively straightforward to reduce and to get to zero. It's our scope 3, which we make the biggest impact, which is about the designs we produce. So our engineering solutions target reduction through a number of different ways. There's real opportunity and no single silver bullet. So we are focusing on innovation and refinement of material specification, including use of low or zero carbon concretes such as AACM and more use of structural timber. We're looking at how we can better refurbish and enhance the designs of existing buildings and designing for long life. We're using technology in our designs to ensure that they are optimized for where we are using investing carbon in the materials in the shorter term, and also using technology and digital tools to help us innovate and find zero carbon solutions. Many of these solutions embrace the ideas around modern methods of manufacturing and construction, which allow us to live to the principles of circular economy and whole life carbon assessments. And I'll touch on that as most of my presentation today. And of course, there's further investment in R&D needed to test and develop these ideas. And a fundamental, I believe, is ensuring that we measure the carbon on every project so we understand where that carbon investment is, how do we reduce it, and how do we avoid it. And we've developed our own tools to support that. So a reminder, a lot of carbon comes from the embodied carbon of construction materials and the construction process. We are in the process of developing a path, the diagram on the right, of how do we, over the coming years, reduce the amount of projects we do which are traditional, the orange there, by doing less bad, by sharpening our pencil, refining what we're doing, but continuing to use an extent of the current materials of predominantly steel and concrete, which are both very carbon intensive. What we're of course aiming for is to avoid materials and going to the grey bars, which are zero carbon projects. Many of our clients are progressive and focusing on those areas, and we want to grow those grey bars as fast as possible and avoid the traditional materials. But we're in a transition as an industry, and I think it's appropriate that we recognise the transition, but don't let that be an obstacle or an excuse. We need to find innovation. We need to find alternatives. Mass timber is one of those alternatives. Timber's been a structural material for millennia. It's a great structural material. It has challenges around fire performance and acoustic, and I think there'll be issues of supply as timber's used more and more as well. But we've done several projects in mass timber and continue to see this as a really important material for us to design and specify as structural engineers, particularly on low and medium rise buildings where the challenges can be better mitigated. It's important that we think through as a multidisciplinary team as well how to resolve those issues which go beyond just pure structural performance. Circular economy and designing for reuse, I think, is a really important part of a structural engineer's approach to carbon. And how do we use and invest the carbon intensive materials which are the normal, but in a way where they're able to be reused at the end of the building's life, not demolished and going to waste, as so many of our buildings currently are. And modern methods of construction provide an ability to do that, or a overarching name, if you like. There's no one way which I'm here to sell. I think different projects have different forms of modern methods of construction. This is some examples of volumetric, and where we're delivering volumetric modules. This particular one deliberately incorporated CLT as part of that module, as the ceiling part of the module. But it's a componentized approach to build the module where we've, as a structural engineer, not only had a concept, but seen it all the way through to the detailed delivery of the module system. And the image in the bottom center there is from our 3D printers, looking at testing and developing ways of the modules being able to fit together on site to deal with tolerances, but ultimately at the end of life also being able to disassemble and then reuse the components. I believe hybrid structures are an important part of the way forward as well. This is an office building we are developing where we've gone through assessing it being a full timber design. And with the height of the building and some of the other constraints on the project, in order to keep timber still as part of the material selection, we have reverted to having steel as part of the frame as well. So the steel is able to be specified in a way which embraces the circular economy and able to be disassembled at the end, but we're still able to use CLT floor panels instead of concrete, giving a great product in terms of visible timber, but also using timber as a low carbon material. Hybrid structures, I think, open all sorts of opportunities to use the right material for the right job, enabling more zero carbon or low carbon materials to be used than seeking to use all of one material or all of another. This is another example. Here, a residential example, again, steel frame with the CLT panels dropped in. Interestingly, one of the challenges here is we were led down a path initially to use delta beam type designs, which are great and enable a flat soffit and various other benefits. But because you then fill them with concrete as part of their performance and fire protection mechanism, you undermine the circular economy design principles because you can't then remove that grouting at the end of life to be able to reuse the product. And so we're now moving away from that and looking more at how do we use more conventional sections which are able to be reused at the end of the building's life and upcycled. And then lastly, I think it's really important as engineers that we have data and the tools for decision making. So we've invested in technology to build a tool we call Magpie, and uses our Revit information and BIM information in various ways. A key part of that is being able to extract and monitor the carbon in our projects during the course of design, the life of the design, and then of course at the end of the project. We're able to use this to test alternative options and being able to see where we've got peaks or unusual carbon and compared to our baselines, and make sure we spend our effort there and to eliminate or avoid that. And then tools like on the right is a spider diagram looking to be able to assess alternatives against the various different metrics which a project might have, and through that better communicating as engineers to enable us to make better decisions as projects. We're being able to demonstrate that many of these solutions do not come with a cost or program impact, but they actually come with real cost and program benefits. But we need to be able to communicate that so the right decisions can be taken. So just a final comment. The future is today. We must change how we design and embrace innovation if we are to achieve a zero carbon developments. Designing just to be less bad is not good enough. Thank you.
Great. That's brilliant. Thanks very much, Simon. So before we move on, I've got a question. Really, there's a lot of questions I'm getting in about timber. But the one I've got for you is, obviously it seems to have a lot of really good credentials, particularly if you're using it in that hybrid structural way. What about end of life though? Because at the end of the life of timber, it's quite difficult to recycle, and there's a risk of it, being burnt and releasing the carbon, or even worse, being allowed to rot, which would then release, I guess, methane, which is a more powerful greenhouse gas. How do you sort of respond to that? We can't hear you.
It is a genuine challenge, and particularly. Sorry, I think I'm having network problems. Hello.
Is
that better? Am I back?
Yeah, that's better.
It is a real challenge, particularly on some of the engineered products like CLT, where there's glues and other nasties potentially in it as well. And that is something I think the industry hasn't yet fully understood or has the right answers for. And we are now not counting it as a negative, like the sequestration of the carbon is something we're taking out of the equation because there's a strong likelihood at the end of the building's life that timber will rot away or be burnt and that carbon released. So therefore we're borrowing the carbon rather than sequestering it. but that's still a lot better than the very carbon intensive processes of burning coal to generate virgin steel, or the huge energy input and carbon release from cement manufacture. So it's not magic bullet, but it's still a lot better than those traditional materials.
Right, I see. No, that's interesting. And another quick question. I mean, you touched upon sort of fire issues around timber. We've got somebody actually saying that it's a real problem for them not being able to use timber because of fire concerns. I mean, are you seeing a lot? I mean, because obviously you're seeing a lot of this with the projects you're doing, or can it be overcome?
It can be overcome in most situations, or many situations. And there's R&D going on as an industry, and we're involved in some of it at the moment, on how to better do it, so that you're not just adding more layers of plasterboard to encapsulate it. There's ways of doing fire studies where you take on board the additional fire load of the timber burning and demonstrate through both testing supported by analysis that the timber burning burns itself out in the charring protection which comes with that. And there's it's not the traditional tick box 60-minute type fire design type philosophy. You need to get into the detail of the engineering of it, and there's some really good fire engineers out there who are really investing in how to demonstrate equivocally that the fire performance is appropriate.
Right, I see. No, that's really interesting. Yeah, because we desperately need that work to be done. Well, brilliant. Well, thanks very much, Simon. So I'm now going to hand over to our next speaker, who is Jesse Putzel, who's the head of sustainability at BAM, and he's going to talk about the construction aspects of net zero. Thank you very much, Jesse.
Thank you. Can you see my screen?
Yes, you need
Great.
to
Nope, that's fine.
The slide. That's perfect.
Thanks very much. And thanks for the first two presentations. Those were really interesting for me to listen to. So yeah, I'm Jesse Putzel. I'm head of sustainability at BAM Construct. So we're BAM's building arm in the UK, and we work on all sorts of types of projects. Do a lot of schools and education, health, and commercial, as well as specialist buildings. So I'm just going to I'm going to use a couple of examples to talk about some of our experience and some of the challenges. I just wanted to start off, as a construction business, we're actually a small property developer. We're a designer, we're a facilities manager as well, but the main part of the business is being a main contractor. But we've had a long-standing commitment to reducing our impacts. So the focus has been on being more efficient, using low carbon sources of energy, and really driving carbon out of the business, and not just by shrinking as a business, but by actually staying pretty steady and reducing our sort of emissions intensity over time. And we've got a range of sort of leading commitments. We're one of the first contractors to have an approved science-based target. We're on the CDPA list. Just about to get a platinum award through CMARS for over 10 years of continual reductions in our emissions. And we're working on some new commitments which will be announced to sort of accelerate our move to net zero well ahead of 2030. I mean, that's all well and good. We want to reduce our impacts, and we're definitely on a track. But of course, it's kind of a matter of scale, and I suppose this is a different way of looking at some of the things you've already seen. So as we transition to that sort of 0 point, which we will get to, we're a very small part of the overall. When you look at one large project, it's actually a project that I'm going to touch on later. Before any kind of optimization for reducing its carbon impact, you can see the change in significance of impact just from the materials of that project. And then of course, if you add in the whole life of that building, it's dwarfing our impact as an organization. So not surprisingly, increasingly, and part of the reason we've made various commitments is we know with clients and design teams need to focus on reducing these two areas on the right. So we're talking about net zero carbon buildings. I suppose as a contractor, we're kind of at the end, or we're receiving aspirations or targets or claims from clients, and being asked to respond to those. And we've seen a massive upsurge in interest, not surprisingly, in the last 12 months, but there's still quite a variation in the aspirations being set, some of the definitions being used, and I think there's still opportunity to do better there. And it's great to see the likes of DFE actually being very clear on what their aspirations are and setting some really robust targets, and we are seeing more of that. But there's still room for improvement, and we're seeing some lost opportunities as well, where we're considering or where costs sort of now is trumping potential cost savings and benefits later down the line. So I think because of that, just before getting into a couple of examples, I think we need to be really clear. So we need to be clear on our aspirations right from the start, and all the work that's been done through the Advancing Net Zero programme with UK GBC is starting to gain traction with this. We also need to be realistic. So realistic in terms of what getting to net zero means and by when. Not all buildings or building types that are still needed within society can be self-sustaining, for instance, through in energy terms, through on-site generation. We need to consider the buildings we build now in the context of a wider decarbonisation of our systems in the country. But of course, we also need to be challenging, and for us, challenging to push energy efficiency and energy demand down as far as possible is the sort of #1 priority. Challenging on views of costs. We've had very real examples where net zero opportunities of kind of or future net zero enabled buildings have been scaled back because of initial costs. And then maybe, controversially, even challenging whether we need a new building in the first instance. And lastly, it's fairly obvious, everybody talks about collaboration, but it's really important from early stages, obviously for us as a contractor, and collaborating with the supply chain from early stages is key to achieving net zero. And also not having that collaboration stop when we finish a building, but picking up on Crawford's points, actually carrying that through to the operation of the building. So then just a couple of examples which kind of speak to some of those things. So in terms of operational carbon, we completed a project with Lincoln University, their new medical school, this year. So the university has a strong net zero ambition for itself as an entity. We came to this project early on, and working with the university, it actually had talking about definitions, it had a particular approach to achieving net zero. We came into the mix and proposed a different approach, aligning with the UK GBC framework definition, which at the time had just been launched. And this led to a really collaborative process, moving to an all-electric design, moving towards a real focus on energy performance throughout, and then obviously a real focus on how that building got handed over, and how it's going to be optimized over its life. So we look at this as a kind of net zero enabled building, and in terms of how it performs, there are no energy use intensity targets within net zero definitions for medical schools, but in terms of how it performs against the commercial offices, it's pretty good, considering this is a much more energy hungry type of building. But I think this kind of speaks to that point about being realistic, because actually the university has achieved something great here, and they've got the ability to operate this as a net zero building in the future. And then another thing that was key for this is that collaboration and a focus on performance throughout. So throughout the design and construction process, but then also, we're there for 2 years working hand in hand with the university, remotely monitoring and measuring the building through a digital twin, and working with them to optimize performance. So then a big issue and increasingly important for us is embodied carbon, not least because when we talk about operational carbon, these are impacts that are happening in the future at some point. Embodied carbon is impact that's happening today. I mean, when you look at our business, in a given year, the kind of collated carbon impact of materials could be as high as, they go into projects that we're delivering, could be as high as 600,000 tons of CO2. So it's a big chunk to be going at. But it really needs, there hasn't been enough focus on this historically, and it really needs to be addressed early on. And I've just got a couple of examples. So again, this year we finished, it's actually our largest project to date for Argent in King's Cross at T-Zone. And this had a focus on driving down embodied carbon right from the start. I mean, it is a very large building and it's still built out of concrete, but it really was the first time we'd been involved in a project with this kind of focus and collaboration. And as you can expect, there was a lot of work done to optimize the design, to look at different options, and actually cost and carbon were looked at alongside each other. And there was a lot of engagement with the supply chain from a kind of getting data early point of view, but also in challenging specifications. And in the end, you know, we've collectively managed to take 10,000 tons of CO2, which for us, when we think about our organisation, is more than our annual operational carbon emissions now, that they've been driven down to below that figure. So it's proved a real benchmark for us to work forward from. And then at the other end of the scale, what does a net zero carbon in construction building look like? I mean, just briefly, this is our first net zero carbon in construction project, against at King's Cross. A very different approach, very different type of building, but a real sort of milestone for us and the development there. So again, there was a total focus on low carbon, both operationally and embodied. It's an all timber structure, all timber building, really lightweight substructure, use of low carbon materials outside of the timber as well, like low carbon zinc facade cladding. And actually, this got so low that we decided to take it that step further, and the UK GBC guidance had just been released earlier this year. So we've offset a very small amount of residual emissions from the project. It is obviously completely different scale, but I think this is a huge challenge. Not every building, we just talked about the difficulties with timber or perception of difficulties. Not every building can take this same kind of approach. It's not transferable. So there's a huge challenge to tackle here. And just the last point I wanted to make was around, you know, it picks up on the points around circular economy. We really need to be using less. And there's a lot of existing buildings or existing materials that could be used. I won't go through these in detail, but you know, when we think about getting to the challenging targets that we have to meet, we've got to consider building and material reuse now, but also for the future. Thank you.
Great, thanks very much, Jesse. It's really interesting. One question before we move on. I mean, you've got to marshal a pretty long and diverse supply chain, haven't you, on projects? And presumably at the end of that, there are SMEs who are quite far removed from you. I mean, how do you, when you're doing a net zero project, how do you kind of get the message out there and ensure that all aspects of that long supply chain are going to embrace the net zero carbon agenda? And are there any forms of contract or other mechanisms that would make it easier?
That's a great question. I wouldn't say we've gotten right to the end of that supply chain with the net zero message yet. It is a big challenge. What we have done where this has been a focus, and it's still not every project, obviously, although hopefully it will be going forward, is carbon and those related aspirations forms part of the discussion from the first stage of communication with our supply chain. Now, whether it then cascades down to the sub tiers is probably where the bigger challenge is. But we make it part of our procurement process, part of our contract requirements, not just up front, but then in terms of, you know, data that gets provided later on. There's a huge education piece to do. I mean, we're working increasingly within a sort of a growing number of sort of material suppliers to talk about carbon, so less subcontractors, and so that we can have that direct link with them, and in some cases, you know, upskilling them in terms of, you know, where they don't actually have a view on the carbon impact of their products, and helping them to to sort of make that transparent through producing EPDs, for instance. So, but there's a lot more work and education to do.
Great, thanks very much. So over now to our last speaker, Simon Wyatt, who's a part of Cundall, is going to talk about the costs and what happens if we don't get on with this quickly.
Can you see my slides now?
Yeah, just need to maximise your screen.
So, good morning, everyone. My name's Simon Wyatt. I'm a partner at Cundall, leading our sustainability and net zero carbon programme. And today I'm going to be taking a slightly different angle and talking about timings and costs. And I just want to reflect on the mad kind of 12 months we've seen in net zero carbon. We've obviously seen a lot of definement of the definitions and terminologies we're using. And with organisations like the UK GBC, the Whole Carbon Network, LETI, they're all starting to converge and have a clear and concise message of what we're actually trying to achieve and how to go about achieving it. If we just go back and reflect on a couple of those. So in terms of timings, the key message from the World GBC Advancing Net Zero project is that we should be aiming to get all new buildings to be net zero carbon by 2030 and all existing buildings in operation by 2050 with the whole life carbon, including embodied carbon, of the buildings by 2050 as well. Today, I'm going to be focusing more on the operational energy side. We've heard some very good stories around whole life carbon and embodied carbon and how to go about reducing it. But the question is really how to focus on existing buildings, because at the end of the day, 80% of the buildings which will be in operation in 2050 are already built now, and we have a huge challenge of decarbonising them as well as new buildings. So just going back to those definitions we were talking about earlier. So I think over the last year and a half, we've really come to understand the difference between carbon neutral and net zero carbon. So carbon neutral, which was bandied around for probably about the last 4 or 5 years, is just basically removing as much carbon as we put into the atmosphere, which is good. And a number of businesses are now carbon neutral certified. But the next step forward and where we really need to get to is net zero carbon, which is basically reducing our emissions in the first place down to a point which aligns to the Paris Agreement 1.5 degree scenario, and then removing any residual emissions associated with that. So it really is focusing on reduction strategies first and significant reduction strategies in alignment with the Paris Agreement. The absolute end game, and what I'm working with a couple of developers on, is their absolute zero carbon strategy, which is basically to get down to zero emissions, which is going to be extremely challenging. And as the last presenter indicated, this is really where we really need to start working with the supply chains, because we can see that net zero carbon buildings are just about possible now. It's extremely challenging. Absolute zero carbon is a long way off, and the only way to really get there is with the full supply chains looking at their carbon emissions and how they reduce those down. And as I said, a number of the most forward-thinking developers are starting to look at this and set themselves targets around that absolute zero carbon. The main framework which most people refer to is still the UK GBC, and it's really clear and concise, which is to reduce construction impacts and have those clearly aligned science-based targets on the construction side, reduce operational energy in line with the Paris Agreement, and then provide that energy in accordance on-site from renewable sources, and when not possible, off-site, and then offset any residual emissions. Just as I said, I'll focus now on the operational energy and the intensity targets. As I said, we need to align with the Paris Agreement targets and move towards a net zero carbon economy as a whole. The way we do this is to phase out fossil fuel use and move to a all renewable grid. The only way we can do that is by increasing the amount of renewables we actually produce in the UK, but also reducing demand. In order to kind of meet the net zero carbon requirements, we're going to need to double or potentially even triple the renewables supply we get, but that will only supply so much. In order to have an equitable, fair share across all industries, we're going to need to see significant reductions. And in simple, for buildings, that roughly equates to about a 60% reduction. That's both for the operational energy and the embodied carbon. So we need to be 60% better than best practices at the moment in order to align with the Paris Agreement and that science-based target trajectory. There are a number of investment funds and hedge funds which are starting to look at their existing portfolio and how they can actually start making these reductions to align their buildings and assets in accordance with the Paris Agreement. One of the main mechanisms for doing so is a system called CREM, which is basically using science-based targets to set trajectories for different types of buildings. So you can look at individual buildings, or you can look at a portfolio of buildings, which basically has a rolling target reduction. So a year-on-year reduction to 2050, which makes basically aligns you to the Paris Agreement. The idea is, though, that you get to the end target. For an existing building, what you do is you basically look at your current emissions, which probably will be, if it's a good building, best practice building, it will be below that trajectory now. But if you don't do anything to that building over time, as the trajectory reduces, it will come a point where you actually exceed that emissions trajectory. This is known as a stranding point, where basically you're no longer in alignment with the Paris Agreement, and that asset will potentially start getting a brown discount and less investment. And with the government's net zero carbon targets, which are legally binding, they're also likely to start penalising buildings which do not align to the Paris Agreement. So there could be taxes or fines associated with not achieving compliance with the Paris Agreement trajectories. And the government at the moment are talking about introducing mandatory energy performance ratings for existing buildings, which would start this process basically. So I'm working with a number of large portfolio owners and landlords, and what they're looking to do is map all of their assets and actually understand how they're operating in use, and then setting pathways for those individual buildings so they don't hit that stranding point. So the only way to do that generally is to retrofit those buildings, make them more energy efficient, take interventions to move those down, and that basically pushes the stranding point further, where you might need to do second or third retrofit. The way that that's done is looking at individual assets, understanding their energy intensity as it is at the moment, setting a target in alignment with the climate science, and the date for that could be 2030, 2050, depending on the client, or as fast as possible for that individual asset. Once that's understood, you can start modeling and building digital twins to look at potential interventions, things like moving to all electric, installing heat pumps, real focus on fabric first to reduce the energy performance, and introducing things like mixed mode and natural ventilation. And obviously behavior change is important. For existing buildings, it's not as simple as just carrying out those works. Obviously, with where you've got sitting tenants, plant and repair schedules, you need to factor those in and schedule them out. And that could be over a 10, 20, or even 30-year period, depending on when lease breaks come. And this kind of shows the importance that when you do get possession of floors and buildings, that you really need to go in and take the interventions you can do now, because if you don't and you miss the opportunity and then you sign a new tenant up for another 10 or 20-year lease, then it could be 10 or 20 years before you could actually achieve net zero carbon for that asset. So it's a huge challenge. We've got 27 million private homes that need to be decarbonised, so 60% reduction generally on most of those homes' energy efficiency. If you think about every school building, education building, office, hotel, every building that you walk past needs basically to have a significant intervention in order to get down to an equitable fair share of energy use. What is interesting though is for new buildings, and what we've seen over the last couple of years is a lot of people aiming for net zero carbon and trying to define that. And the UK GBC and REBA have set step trajectories in order to become net zero carbon. And this seems very logical. It seems to be following a similar trajectory like the CREM methodology. So as we go forward, the energy intensity targets reduce from 170 to 110 to 55 from REBA, and you can basically design a building to be net zero carbon. But the problem with this is it's a bit of a false economy, because if you build a building in the next 2 or 3 years, which is net zero carbon to the 2025 standard, your building's only going to be net zero carbon for a short period, and then you're still going to have potential stranding events. You can move the step up to 2030 and move the stranding event to later. But basically, you're designing a building which will need to be retrofitted or refurbished in the first 10 to 20 years of its life of its operations. And who wants to and who can afford to retrofit a new building? So although design teams are pointing out that, and there's been quite a few studies done now, indicating that at the moment the cost uplift to go into net zero carbon on day one is somewhere between 5 and 15%. You have to think about it in the over a life of the project, or even the first 20-30 year life. If you look at a project with a cost uplift of 10 to 15%, yes, it's a significant cost uplift. But if you don't do that cost uplift now, you're going to have to potentially do significant works in the first 10 to 20 years of its life. And the cost of doing those works could be significantly more than 10 to 15%. And it comes to one of my key points, which is basically you really need to get the fabric first. So maybe you might want to replace the services and reconfigure the HVAC systems after 20 years and move towards net zero carbon then. But what you don't want to be doing is rescaffolding and recladding a building or doing significant works to the facade within the first 20 years. So it's really important that if you're building any new building in the next couple of years, you really focus on that fabric first approach. Yes, there might be a small cost uplift associated with doing so, but the cost of doing those works in 20 years' time is going to be significantly more. And also think about the embodied carbon. If you're doing refurbishment, there's going to be more embodied carbon works required later on down the line. So it really pays, but in financial terms and carbon terms, to carry out the works as soon as possible in order to drive those net zero carbon solutions as quickly as possible. So that was kind of the end of my presentation, and trying to re-emphasize the time to act is now, and we need to reduce the carbon emissions of all new buildings whilst also looking at pathways for existing buildings, which is the major challenge.
Great, well, thanks very much indeed, Simon. I've got a question for you, which is actually maybe a bit provocative, but I've also, it could be addressed to everybody else. So, I mean, everyone's outlined the scale of the challenge, and you mentioned sort of net zero by 2030. Do you think the industry can do this? Can we achieve it?
Yes, as we've seen from the examples, there are projects which are achieving significant reductions and aligning to the science, but I'm working on quite a few projects with a lot of design teams at the moment, and cost is becoming a major driver. But where we are working with universities, housing associations who are taking a long-term look at cost and understanding that they might have to do retrofit work in the period in order to hit that 2050 target, then they're seeing it starting to stack up to make financial sense, because it's basically managing risk. If you don't increase the fabric and performance, then you might have to pay significant penalties down the line. So it's safeguarding any investment. And what's most interesting, there's been a few studies recently done indicating that yes, there is a cost uplift in terms of fabric first approach in terms of insulation, air tightness, and that's coming down over time. We've obviously seen significant reductions in the cost of delivering passive house. But what is interesting is where people have been designing to things like the GLA London plan, they've had increased costs from fabric, but they've not taken savings on their HVAC systems and MEP. If we can really get the fabric first approach right, we are significantly reducing the requirement on HVAC systems, which means we can take significant cost savings. And Arabs and Coley and Brown and a few others have done studies indicating that the cost of actually going to full net zero carbon can be actually cheaper than going to GLA compliant design, because you're taking savings associated with stripping out equipment and installing equipment. So yes, it is possible. It's extremely difficult, but we can just about get those kind of 50-60% reductions we're talking about. In order to go further to the absolute zero carbon, which a few clients are looking at, the supply chain is going to be really vital going forward.
Well, thank you. And I'd like to bring everybody else into the discussion. If you could all put your cameras on and microphones. We don't actually have an awful lot of time left, to be honest. Anyway, so I mean, really following up to my question to Simon. I mean, we've got sort of various, we've got the future building standard and the future home standards sort of making their way through the consultation process. Do you think we need more regulation? I mean, do you think there's no regulation at all on embodied carbon other than the London Plan, who are now making it a requirement for developers to submit a calculation, but at the moment that's not, you know, there's no target. Do you think we need a sort of a faster approach and sort of really getting down now to embodied carbon and regulating on that?
I'll take that. Yes, absolutely. Embodied carbon needs to be regulated as soon as possible. It needs to go into the regulations. It's where building control could actually be effective, because we can report fairly accurately now the upfront embodied carbon on practical completion. There's no reason why you shouldn't regulate it. Building controls can sign it off. What's interesting is building control at the moment have power on operation energy, but they have no influence on it because they sign the building off on practical completion before any energy is actually used. So what is really important, and what we're seeing from the government at the moment, is going to be the introduction of mandatory performance standards for all buildings. So this will in effect be a league table of all buildings and their actual performance. And what will be interesting will be the penalties will be marginal, as we've seen from the government before, but it will be the reputation. If there's a big league table of all buildings online, you're going to be damn sure no landlord or investor is going to want to be near the bottom of that pile. They're all going to be aiming to be at the top, and the universities are going to be competing to have the best performing buildings on there as well.
Sure.
Yeah, I would support that. I think the reporting and the transparency is important. That will drive better behaviours, and then regulation is important to continue to increase the minimum standard. But we'll only achieve the outcomes if we actually have progressive clients who want to do this, because it makes the value of their building a higher value because of how they can sell it or rent it. And certainly our more progressive clients are seeing that now, and they're taking the view well ahead of regulation because they see the value in doing it. And then the regulation just needs to lift to mop up a bottom minimum standard.
Okay. I mean, another big area is manufacturers. I mean, what is your experience of manufacturers? I mean, are manufacturers really sort of beginning to address the kind of impacts of their you know, extraction and production processes? And are they providing, you know, are you getting enough information from manufacturers in terms of you know, APDs, any kind of indication of the embodied carbon content of their products?
I'll give a view, if you like. I think that there are some great examples. I mean, there's the big manufacturers that have been doing, you know, life cycle analysis of their products and processes for years. The big, you know, conglomerates that do actually make up a lot of our buildings. But it's such a vast area, and obviously there's the whole, you know, we manufacture very little in this country anymore, and there is this big sort of off-sighting of carbon impact that's happening. But there are some great examples. I mean, we've worked with a UK lighting manufacturer that's innovated a new approach, all really based on circular economy, but in doing that, it's driving carbon out of the life cycle of their products. But it's few and far between on that front beyond the big manufacturers. But you know, the likes of concrete, they do have their trajectories, again, the big companies, towards their own zero carbon. But I think there's a lot more that we can do. Certainly, as from a contractors and designers point of view, I think getting a lot closer to manufacturers is really key in having a discussion about what could change and then how we could support and enable that. And that's kind of what we've done with a small group so far, but that needs to increase.
Supply chain charters are going to be really important going forward. Like, the most forward-thinking developers and clients are really starting to work with their supply chain and introducing phased supply chain charters, which is at the moment is working with them in collaboration, setting requirements for them to report, then setting minimum performance requirements over time, and really trying to push them. But it comes back to, even when you're looking at corporate level, when you're setting a net zero carbon strategy for a business, it's all about data, and you need to basically go to your entire supply chain and ask for the data. And most of them won't have that data. and only over time, as more and more of their clients ask for that data, will that get better. We've obviously seen it with embodied and whole life carbon. Structurally, it's really come a long way in the last kind of 5 years. It used to be very ropey calculations. Now the accuracy of structural calculations is great. Now we're just starting to see the beginning of building services. We introduced TM65 earlier this year, but to be honest, the calculations and quality of calculating body carbon and building services is so bad at the moment, but it will only get better by improving EPDs, asking the supply chain to do it, because then they're going to really start to focus on it. So yes, just keep asking, work with your supply chain and make sure that they can provide the data you need.
Well, thank you. Well, on that note, we're actually out of time. So I'd like to thank all our speakers for a really interesting discussion today, and one topic we'll be definitely revisiting quite a bit in the future. And to advise our audience that this webinar will be available to download on demand. And thanks to everybody for listening.
Thanks very much.
Thanks all, bye.
Thank you.